Hello fellow math enthusiasts and learners of mathematics. This video, as the title suggests, is about translating English phrases into algebraic expressions and getting it right. I'm going to give you in this video math and physics examples, and I'm going to lay it out math first, physics second, and we'll mention a couple of talking points. Some of it are completely omitted from the textbooks because it's not really dealt with either in physics because it's assumed to be obvious, and not really dealt with in math books because it's borderline physicsy. So let's get started with math first, the basics first. Here are a number of English sentences. This one is an addition example, multiplication example, 2 subtraction and 2 division examples. Here all of them feature the word a number. What do we do with these? And it doesn't matter, a number and whatever quantity is also listed in the sentences, 2, 5, 10, 3, whatever. So what do we do with this number word in red? Then for in algebraic expressions, the word number in red can be replaced with a letter N, capital uppercase letter, or a lowercase letter. It can be replaced with any letter from the English alphabet if you like the English alphabet, or it doesn't actually have to be the English alphabet. It can be any alphabet and any symbol. It can be the Greek alphabet, alpha, beta, and why not pi. So any letter can stand in for the word a number. Now obviously pi is used in circles, alpha and beta are used typically in math with geometry, in angles, so the word number here can be also replaced with an angle and 2 degrees, whatever. But especially in equations, Greek letters, equations used in physics and applied math, Greek letters are picked in formulas for coefficient of friction or whatever, a number of things. So a coefficient of friction and something else can also be same. Works with the same logic here. So that's how you write down a number or an angle or a thing that is not further specified. You just pick a letter from any alphabet, literally. Now, a couple of letters are not picked. So I'm gonna make them, I don't know, red or something, because they are problematic. Actually, not red, I'm gonna choose another color, blue. Lowercase letter O in the English alphabet looks like a 0. Uppercase I looks like a 1, and I'm going to put an uppercase I and the lowercase l side by side, so that's L and that's uppercase I. Good luck telling the difference between the two of them. And if I put a 1 next to them, so in the digit 1 in some fonts, they may not have this horizontal line at the bottom that is called in printing terms, it's a serif, so it may be sans serif versions, and so they can be confusing. Also cautioning about using the letter X because it looks like a multiplication symbol. However, it's used widely in math. So, but these letters are typically or could be problematic. Now, so how do we write a number and 2? So pick any letter except, watch out, a number and 2. So for a number, I'm gonna pick, I don't know, K, and K is a fine letter, so I'm gonna just change color on it and go back to K plus 2, there, a number and 2. The word and here is replaced by, or is symbolized by, the plus sign there, and 2 is 2. Now, this being addition, it can be written backwards because it's commutative. Commutative means, again, it can be read from left to right or from right to left, because 3 plus 2 is the same as 2 plus 3. Now, in English, we read these things, and in a number of other languages, we read sentences from left to right. So you print your algebra from left to right, but this can also work. Full marks, perfectly fine answer. Multiplication works the same way. It's also commutative. So a product of, so you know this is a multiplication story, a number. So you write down a number, I don't know, G, and write down the number 5. Again, any letter can be used, I don't know, D, whatever. And you can write them, or X. Now, and you can write them backwards as well, but again, X here is problematic because it can look like a multiplication symbol. However, if I write them the other way around, 5x, now they look familiar. However, the sentence here, a number and 5. So, a number and 5, this matches the sentence, but this is equally correct. As long as there's no confusion that this x is not a multiplication symbol, and if this 5 is printed neatly enough, so it's not mistaken for an exponent, x to the power of 5. You see the difference? Okay, so if it's printed neatly enough, you'll be fine. So this is how math is typically printed: 5x, 5y, 5a. However, this sentence can also be written as the product of 5 and the number, 5 and the number. But here we have this way, a number and 5. Either which way, full marks, left to right or right to left. As long as it's clear, it will work. The same is not going to happen with subtraction and division because they are not commutative. This is not about order of operation. This is reading from left to right. So difference of means is going to be a subtraction story, so keep that one in mind. The first thing you see is the amount, 10, so that's what you write down, 10. Then the subtraction symbol, and then for a number, pick a letter, 10 minus x, that's 10, difference of 10 and the number. You can use, of course, other letters, 10 minus, I don't know, how about alpha? Full marks, either which way. However, what is going to be unacceptable, so no x minus 10. So if you read it from left to right, that's how you write it into an algebraic expression. Do not write it from right to left because it just means different things. So let's say x equals 2. So 10 minus 2, that's 8. Let's put the same 2 here. 2 minus 10, that's not 8. That's negative 8. Completely different thing. Okay? So don't be reversing the numbers, the algebraic expressions here. You cannot do that with subtraction. So however it's written in an English sentence, that's exactly how it should be in the algebraic expression. The same applies to division, of course. So division can be written a number of different ways as well. So 3 divided by a number, or it could be written with 3 divided by a number like so, I don't know. Or fraction format also works with the numerator and the denominator. So 3 and a number, how about x? Now this looks familiar as a fraction. All of this is the same division story. Again, you read it from left to right, and that's how you print it from left to right. But with this fraction format, you see it's not left to right anymore, it's top to bottom. But I started with these ones because it's obvious that you write them from left to right. Now, this is going to change, of course, if the sentence is printed this way, the quotient of a number and 3. So you're going to have to start with a number and 3, or a number with the division symbol divided by 3. And in fraction format, it's gonna look, I'm just gonna switch it around. X goes there and 3 goes into the denominator position. So it's no longer from left to right in this fraction format, it's from top to bottom, but you get the idea here. So and these are the issues when it comes to writing algebra correctly. Now, the next talking point concerns physics, and in physics there are special words such as speed, time, distance, voltage, I don't know, friction, these kind of things. Now, I printed the word speed here in red because it's essentially the same noun taking up the same place as the word number in these sentences. So twice the speed is twice a number. Pick any letter for it. Now in physics, it tends to be, or in some word problems, it tends to be the tendency, or it's usually good practice to write it twice the speed because the initial of the word matches the letter that is abbreviated into an algebraic expression. Twice the speed, twice the velocity if you want to go fancy, but plain old 2x is just as good, full marks. And this being multiplication and being commutative, if you write it backwards, it's also good, as long as there is no confusion what it's about. V2 is the takeoff speed in an aircraft, and there's also a V1, so watch it. You might run into problematic areas with notation here in physics. Now, there's one other issue with physics that's not explained much in physics books or math books, but is assumed to be obvious, and it's absolutely not. Here's a sample sentence. The difference of final temperature and initial temperature. So essentially the difference of a number and another number. Okay, so how do you write these? Well, temperature can be abbreviated with the letter T, and you see that the adjective initial and final are, we need to do something with them. What they do in physics and applied math is this. Temperature final, temperature initial. You see they put the adjective after the noun, such as in some languages where the adjective follows the noun. So instead of blue house, it's house blue in some languages, okay? And something like this happens here. So temperature initial and temperature final are abbreviated like this. This is called a subscript. So if I give you an example here, let me just move over here a couple of spaces and pick another letter, say K, and I want to make a subscript for it, like X would be the subscript. Just highlight that and make it into a subscript like so. Okay, so this kind of notation is called subscription. It's not an internet or a magazine subscription to whatever. This is a subscription in this math sense. Actually, I'm going to leave it there so that it's named. So this is a subscript, and when you write an exponent, let me just make an exponent over here, just k to the power of 5. This one is a superscript. Yes, it's an exponent. So this is a subscript and this is a superscript. So the letters here are subscripted, okay, for final initial temperatures. So what does it mean, final temperature and initial temperature? Let me give you a plain example here. you're cooking, baking something, and you set the oven temperature initially to 325 Fahrenheit, and then you change your mind and then you change it to 375. So initially 325 and then 375. So how you write it is this. Of course, 375 minus 325 is 50. The difference of the final and initial temperatures is 50 degrees. This is how it's written in physics with subscribed indexed letters for temperature. I have here another number of examples here that I can pull up. The same works with time, time final, time initial. You know, when you started baking and when you finished baking, say it was I don't know, 9 a.m. when you started, when you finished it was 10:30. So the difference between final time and initial time, hour and a half. The same works with pressure, pressure final, pressure initial. Say you're inflating your tire on your car, it's a little bit flat, say 20 psi, down to 20 psi, it should be up at 32. The final pressure should be 32. The difference between final pressure and initial pressure is 12. 32 minus the 20. And one other letter here, it works with voltage or velocity, whatever, pick one, and forces as well. So this is really frequently used in physics where change is tracked and quantified. Okay, that's what I wanted to share with you. That was the last talking point here. So keep in mind when you're writing algebra, these notation conventions or practical things you're going to come across, as well as the ones that I mentioned, that notation in addition and multiplication can be left to right, reversed, but not in subtraction and division. Print your numbers neatly and your letters neatly so it's clear what the algebraic expressions are. Thank you very much for watching.